हम लोग इस वीडियो के माध्यम से मैकेनिकल प्रॉपर्टीज ऑफ रिइंफोर्समेंट स्टील की स्टडी करेंगे। इसकी स्पेसिफिकेशंस IS 1786 में दिए गए हैं, जबकि इसको टेस्ट कैसे, इस पे टेस्ट कैसे किया जाएगा, मटेरियल पे टेस्ट कैसे होगा, इसका प्रोसीजर्स IS 1608 में दिए गए हैं। टेंसाइल टेस्ट के माध्यम से हम लोग रिइंफोर्समेंट स्टील के यील्ड स्ट्रेस, अल्टीमेट टेंसाइल स्ट्रेस, इलॉन्गेशन, परसेंटेज रिडक्शन इन एरिया, यंग मॉडुलस इत्यादि को फाइंड आउट करते हैं। ये बहुत ही इंपॉर्टेंट प्रॉपर्टी होती है टू इवेलुएट द प्रॉपर्टी या मटेरियल। उसके कोई हमें नया मटेरियल डेवलप करना है तो भी मुझे टेंसाइल टेस्ट की उसकी जरूरत पड़ती है। और हमको क्या कहते हैं, क्वालिटी कंट्रोल में द मटेरियल विच वी आर रिसीविंग फ्रॉम द रिसर्च, वो कितना स्पेसिफिकेशंस को मीट आउट कर रहा है, नहीं कर रहा है, उसके बारे में जानकारी हासिल होती है। So let us start the tensile test of the reinforcement steel. Reinforcement steel के tensile test को evaluate करने के लिए we use the UTM of different capacity, universal testing machine different capacity की, और right from 5 ton, 20 ton, 40 ton, 100 ton. These are all depending upon the requirement are available and which is used for the determination of tensile properties of the material. So in UTM there are generally three parts: upper class head, lower class head, and middle movable class head. The specimen for the tensile test is placed between the middle and the upper class head in the grips, and there will be a control panel, and for recording the measurement there will be nowadays computers are being used. Otherwise there will be some enlarged display unit will be there, where from we get the strength parameters, elongation parameter, etc. So the test piece is placed in the upper class head in grip and lower grip, and then tensile force is applied till it fractures. So tensile test is carried out. Tensile test on rebar is done to find out various mechanical property. It is carried out for evaluating the properties of material, Second, development of new material. And most important is quality control. Quality control of the reinforcement received at site. How much weight per meter? What is yield stress? What is ultimate stress? All this is find out from the universal testing machine by doing the tensile test. So the parameters which we determine from the tensile test are yield stress, oblique 0.2% proof stress. In case of low carbon steel, we find out 0.2% proof stress, because the yield point will not be defined. We will not get on the stress strain curve a definite yield point, so we go with the 0.2% proof stress. Then ultimate tensile stress, then maximum force. We find how much maximum force taken that material before it fractured. So that gives us the ultimate tensile stress, then percentage elongation. Percentage elongation. All this we find out with the help of tensile test. So important parameters are yield stress, ultimate tensile stress, and elongation. So yield stress is a point corresponding on the stress strain curve. There is a increase in strain, increase in length without increase in the force. So the point which reached at during the test जो maximum point होता है जहाँ के बाद में material will not regain its shape and size, it will go for the permanent deformation in the plastic region. So that is the point which is that is the force taken for the calculation of yield stress. So force at which plastic deformation occurs, the force at which the plastic deformation occurs without increase in force. So we can define it as stress corresponding to point during test at which permanent deformation or plastic deformation occurs without increase in force. During the test, जहाँ पर वह लोकेशन या वह फोर्स जिसपे परमानेंट डिफॉर्मेशन प्लास्टिक डिफॉर्मेशन occurs in the test piece, that is known as the yield point, and the corresponding force is taken for the calculation of yield stress. So in the force versus elongation curve, there will be a point at which there will not be increase in the force, but there will be increase in strain, and that is the point where the permanent deformation first time takes place, and that point is taken for the calculation of yield stress. It is for the low carbon steel. It is determined with the help of 0.2% proof stress. So what is the tensile strength? Tensile strength is the point corresponding to the maximum force in stress strain curve. So stress point corresponding to maximum force. The test specimen where it takes maximum force and thereafter necking will occur and the force will go on reducing till fracture. So that is the upper point is taken as the ultimate stress point, and the corresponding load divided by area is ultimate tensile strength. So after that necking occurs and the test piece is not in position to take more load, it will decline and it go to the fracture. So load corresponding to the uh, load corresponding to maximum point is a ultimate UTS, ultimate tensile strength. So a point corresponding on the stress strain curve to the maximum force is a ultimate tensile strength. Elongation is change in the length to the original length. If a specimen, we have taken a gauge length of a specimen, say 5.65, root A is a gauge length, like for 20 mm, it is about 100 mm gauge length. If we press into the tensile testing machine, it elongates. When we apply the tensile force, it elongates till fracture. So there will be increase in the length, that is the delta L, means from the original length how much it has increased. So increase in length represented by LU minus original length divided by original length, it is expressed in the percentage. So elongation is nothing but difference between the elongated length to the original length divided by the original length. So we find out the elongation, how much material has elongated uh, before fracture. So we combine the test piece and find out the gauge length. Say earlier it was 100 mm and now it is 114.5. So the elongation in the material is 14.5 divided by 100. So elongation will be about 14%, 14.5% of the that test piece or that reinforcement bar, that dia of reinforcement bar. So selection of test specimen. So we know that reinforcement steels are produced in continuous casting. So different heat means having the same properties. A billet is taken having the same property. All the material produced from one heat will have the same property. So uh, the IS 1786 has given the how much test selection of test should be carried out per heat. So that is serial number 1, sizes of rebar, all sizes, quantity of test piece कितना लेना चाहिए, quantity of test piece, quantity इन क्वांटिटी यदि 100 टन की क्वांटिटी है तो उसमें कितना टेस्ट पीस लेना चाहिए, उसके बारे में IS 1786 में दिया हुआ है. सो इफ हीट लेस देन 100 मीट्रिक टन है तो उससे जितने भी स्टील प्रोड्यूस होंगे उसके टू टेस्ट पीस पर हीट लेना है. यदि हम 8 mm का, 10 mm का, 12 mm का, जनरली एक ही डाया की स्टील प्रोड्यूस की जाती है, तो विद दैट हीट टू नंबर अप टू 100 टन specimen we have to take for the testing, and so 2 number per cast or heat, and if it is greater than 100 ton, so 3 number per cast, and minimum length of steel bar given in the IS 1786 is 0.5 meter plus minus 0.5% precision in the measurement. So minimum length of the steel bar should be taken for the testing is 0.5 meter to the accuracy of 0.5%. Accuracy in measurement should be 0.5%. Now जो IS 1786 में दिया हुआ है कि bars of sizes 8 mm, 10 mm, 12 mm, 16 mm, 20 mm and 25 mm, they should be tested without any modification and deformation in shape. Means जो भी हमें मटेरियल साइड मिल रहा है उसी का टेस्ट स्पेसिमेन मिनिमम 0.5 मीटर लेंथ का लेना है, उसको टेंसाइल मशीन मतलब UTM यूनिवर्सल टेस्टिंग मशीन में प्लेस करना है एंड प्रॉपर्टीज को, उसके टेंसाइल स्ट्रेंथ को फाइंड आउट करना है विदाउट एनी मॉडिफिकेशन इन शेप एंड साइज. बट यदि 28 mm से ज़्यादा का है तो उसके डिफॉर्मेशंस को मशीन किया जा सकता है. जब डिफॉर्मेशन मशीन करके जो रिड्यूस्ड क्रॉस सेक्शनल एरिया है उसको कैलकुलेशन पर्पज के लिए यूज करना है. तो फॉर 28 mm and above machining can be done. If UTM is having say 100 ton capacity, it can break even up to 40 mm dia bar easily. So no need to do the any modification in the shape. Find the result and same can be applied for all in all calculation. If the machine of low capacity say 40 ton, so we can machine the deformations only and press into the put into the UTM and find out the test. So this is the criteria given in IS 1786. So up to bar sizes of 28 say 25 mm, we should use without modification. After 28 mm size, modification can be done. So, mechanical properties which is given in IS 1786 for the material. So, mechanical properties. Mechanical properties of reinforcement steel. IS 1786 टेबल 3 में दिया हुआ है. टेबल 3 में दिया हुआ है. तो दिस सीरियल नंबर, प्रॉपर्टीज, and grade. Say Fe415, grade of rebar, Fe415, Fe415D, Fe500, Fe500D, Fe550, Fe550D. The property, first property is yield stress. Or 0.2% proof stress minimum in Newton per mm square. Unit should be Newton per mm square. So for Fe415, it should be 415 Newton per mm square. 415D, it is 415. For 500, it is 500. 500D, also it is 500 Newton per mm square. 550 Newton per mm square, and 550D, 550 Newton per mm square. Fe 600, so 600 Newton per mm square. And the elongations, percentage elongation. Percentage elongation for the Fe415